Hey, this short video is about the topic that Alex calls binomial problems basic, even though I don't think it's particularly basic of a topic. But anyway, let's take a look at what one of the example problems looks like, and I'll talk through it. So it says Anita's, a fast food chain specializing in hot dogs and garlic fries, okay, keeps track of the proportion of its customers who eat in the restaurant as opposed to ordering to go. So it can make decisions. Sure. Anita's reports that 45% of its customers order their food to go. So 45% to go. I guess that means 55% are eating in. Okay, if this proportion is correct, what's the probability that in a random sample of 4 customers, exactly 3 order their food to go? Okay, so chances that 3 are to go. And 1 is eat in. I think the first thing you should think of when you see this is like, what? What does this have to do with anything? And the answer is it has to do with the binomial theorem that we just covered. This is one of the uses of the binomial coefficients that show up in the binomial theorem. So let's just see what is the probability that if you pick 4 people, that it's in this order: to go, to go, to go, eat in. If it's in that order, then it's 45% for the to go the first time, 45% for to go the second time. Notice that it's 45% of the first 45%, and that of makes it be times. So we're multiplying these probabilities together. So the probability of getting 3 to goes in a row is this: 3 45% in a row. Multiply the probabilities together. And then to get an eat in at the end is 55%. So, okay, I can multiply these together. Where did the binomial coefficients come in? Well, there's lots of different orders that could happen here. It doesn't necessarily have to be to go, to go, to go, and then here. It could be that the here was the second one, or it could be that the here was the third one. Basically, there's lots of ways to choose which 3 out of 4 are to go. If you're choosing 3 from 4 total, then it's 4 choose 3. So there's to go, to go, to go here. That's 1. But in total, there's actually 4 ways you could possibly order this, because 4 choose 3 is 4. Use this trick to deal with factorials. 4 factorial is 4 times 3 times the rest. The 3 factorials cancel, and I'm left with 4 divided by 1, so I get 4. There's 4 possible orderings of like where these would be. So my total answer is going to be this probability times 4. Ask the calculator what this is. Come on, calculator. So I'm doing 0.45 cubed times 0.55 times 4. I get 0.200475. Let's see how Alex wants to answer. Round your response to 3 decimal places. 200. Cool. Does it ever do it totally different? Workers' union at a particular university is strong. 96% of workers belong to the union. Recently they went on strike. They plan to interview 5 workers to get their opinions. What is the probability that exactly 4 are in the union? So you'll do 96% multiplied by itself a bunch of times, and 4%, the opposite, multiplied by itself sometimes. And then you will multiply the result by 5 choose 4. So the binomial coefficient, 5 choose 4 here, represents the number of different ways there are to order, like put those things in order. Like how, no, not really how to put them in order. It's like how to choose which of the 4 are the ones that are in the union. So hopefully that helps. Feel free to send emails, and I'll still have some office hours during the last week of classes. Have a good day.